Next, we'll talk briefly about acid-base titrations. So what is a titration? A titration is when you have a substance with a known concentration and you use it in a reaction with a substance whose concentration you don't know. And then you're able to measure the volume and do calculations to figure out what that concentration, the unknown concentration of the other sample is. So I'm going to link a separate video to talk about how to actually do a titration in the lab, but the point of this video is to do an example of the math behind titrations. So this is kind of like a very introductory level problem. They can get much more complicated than this, but this is kind of the basics of how to solve a titration problem. So for example, we have a titration of 10.00 milliliters of HCl solution. We don't know the molarity. The molarity is unknown. And we're mixing that with 12.54 milliliters of a 0.100 NaOH solution to reach the equivalence point. What is the concentration of the unknown HCl solution in units of molarity? So there's a lot of information here. The first thing I always recommend doing is writing out our chemical equation. So we have HCl reacting with NaOH. So we have HCl plus NaOH yields H2O plus NaCl. So we know plenty of information about our NaOH. So we know that the NaOH has a molarity of 0.100 molar. And we're using 12.54 milliliters of it to reach the equivalence point. So what is the equivalence point? Well, the equivalence point, I'm going to abbreviate that as EQ point, is when the moles of acid equal our moles of base. So when we know that the moles of acid and the moles of base are equal, we can use that information to figure out information about the other substance. Because the problem here is that we don't know the molarity of our HCl, so I'm going to call that our X. But we do know that we have 10.00 milliliters of it. So let's kind of organize this information. Let's start with the HCl. We know that molarity of HCl is what we're trying to find, and that molarity is moles over liters. So that would be the moles of HCl solute over liters of solution. We already know our liters of solution because it just tells us that we have 10.00 milliliters of HCl solution. Easy enough. So we can fill in that information. So the molarity of our HCl equals some amount of moles over, we don't know the number of liters. We have to do a unit conversion for that. So let's come down here and do a quick unit conversion. 10.00 milliliters. There are 1,000 milliliters in 1 liter. Cancel the milliliters. So that means that we are going to have 0.01000. Notice that all of these are significant figures. Liters of HCl solution. So now that we have our liters, we can plug that in to our volume down here on the bottom. So in order to solve for molarity, which is what the problem is asking us for, so remember, It's asking us what is the concentration of the unknown HCl in units of molarity. So in order to find that molarity, the first thing we need to do is find the moles. We can do that because some other information that we have is we have information about the NaOH. And we know that for our NaOH, it tells us that we have 0.100 molar NaOH. We know that molarity is moles over liters. And we don't know the moles. So I've already used x as a variable, so I'll use y as our variable here. So we don't know the number of moles, but we do know the number of liters. So we have 12.54. We'll do another unit conversion. You can write this out on the periodic table, not on the periodic table, in a train track table like we did for the HCl. But I am just going to know that, okay, I'm dividing by 1,000, so I'm going to move my decimal point over 3 places, 1, 2, 3, to get liters. So that is going to be 0.01254 liters. Because we know that information, we can solve for our moles, and we would get that y equals 1.25 times 10 to the negative 3 moles of NaOH. Because this is the volume at the volume and the moles added at the equivalence point, then we know that the moles of acid equals the moles of base. So we know that this value is also going to be equal to the moles of acid that are present in that solution. So that means that that is also equal to moles of HCl. So that's really great because that is going to allow us to finish solving our equation. Because now we'll have our moles of molarity concentration of HCl is going to be equal to 1.25 times 10 to the negative 3 moles divided by 0.01000 liters of HCl. And that will give us a molarity of 0.125 molar HCl. Okay, so my last comment that I have on how to solve these problems mathematically like this is I really, really, really do not want to see you using M1V1 equals M2V2 for titrations. That equation is not supposed to be used for titrations. It is used to dilute concentrated solutions into more dilute solutions. It is not supposed to be used for chemical reactions. So when you're solving these, I want you to actually show out your work the proper way, solving for moles of each substance.